Welcome to Sadlier's webinar on Seeing Progress in Mathematics through the lens of Common Core. My name is Janine Ferrara, and I'm the Director of Product Management for Math and Technology. Also with us is Blair Hembling. She's our Product Specialist. She's going to be assisting me with any questions that you might have during the presentation. Before we get started, I just want to let you know that everyone's microphone are on mute. Everybody's audio is on mute. So should you have any questions during the presentation, just please put them in the chat box, and Blair and I will answer them at the end of the session. If there's something that needs to be answered immediately, Blair will answer them for me. So let's get started. Today, what I'm going to show you is how using Sadlier's Progress in Mathematics print components and online resources together will help you implement a seamless Common Core curriculum. So with Common Core, there are actually three entities. They're the Common Core State Standards, they're the Standards for Mathematical Practice, and they're the Shifts in Math. And what Common Core states is that all three of these need to work together to effectively implement a Common Core curriculum. So what I'm going to do is I'm going to walk you through the Standards for Mathematical Practice, and I'm going to walk you through the shifts. And in turn, we will be addressing the standards for Common Core. So let's start with welcome to Sadlier's webinar on Seeing Progress in Mathematics through the lens of Common Core. My name is Janine Ferrara, and I'm the Director of Product Management for Math and Technology. Also with us is Blair Hembling. She's our Product Specialist. She's going to be assisting me with any questions that you might have during the presentation. Before we get started, I just want to let you know that everyone's microphone are on mute. Everybody's audio is on mute. So should you have any questions during the presentation, just please put them in the chat box, and Blair and I will answer them at the end of the session. If there's something that needs to be answered immediately, Blair will answer them for me. So let's get started. Today, what I'm going to show you is how using Sadlier's Progress in Mathematics print components and online resources together will help you implement a seamless Common Core curriculum. So with Common Core, there are actually three entities. They're the Common Core State Standards, they're the Standards for Mathematical Practice, and they're the Shifts in Math. And what Common Core states is that all three of these need to work together to effectively implement a Common Core curriculum. So what I'm going to do is I'm going to walk you through the Standards for Mathematical Practice, and I'm going to walk you through the shifts. And in turn, we will be addressing the standards for Common Core. So let's start with the Standards for Mathematical Practice. So the 8 Standards for Mathematical Practice are what Common Core sees as the process standards, what students should be thinking and doing while learning mathematics. And these standards apply to all grades, through kindergarten through 12. And I'm going to address them today through our kindergarten through 8th grade program. So these standards should permeate all instruction. They're not intended to be a checklist. So they're not intended to be, today I am making sense of problems, and tomorrow I'm modeling with mathematics, and then the next day I'm going to be attending to precision. That's not the way they're intended to be implemented. They should permeate through all instruction. So there are two ways you could look at the Standards for Mathematical Practice. The first is through the NCTM standards. The 8 Standards for Mathematical Practice were built on the NCTM process standards and the National Research Council's Adding It Up report. So if you are familiar with the NCTM process standards, then you should feel comfortable that you are familiar with the 8 standards for mathematical practice. And I have a slide here to show you how nicely the NCTM process standards fit underneath. I'm sorry, how the 8 standards for mathematical practice fit nicely under the NCTM process standards. And since Progress in Mathematics, we built the program around the NCTM process standards, you should feel comfortable that you are addressing the 8 standards for mathematical practices. Another way to look at the standards for mathematical practice is through this diagram that I cannot take credit for creating this diagram, but a gentleman by the name of William McClung He's a professor from the University of Arizona. He created this, he came up with this document to show that there's an easier way to look at the 8 standards for mathematical practice. And he decided to group them into 4 categories. The first category is this gray area here on the left where it says making sense of problems and persevere in solving them and attending to precision. And he feels that problem solving, and I think we all feel that way, is problem solving should permeate all math instruction. So that should be woven through all of the mathematical practice standards as well as all instruction. But then take the next 2 standards for mathematical practice and think of them as reasoning and explaining. And then take the following, 4 and 5, and think of them as modeling and using tools. And then look at 7 and 8 and seeing that and look at them as seeing structure and generalizing. And they're a little easier to interpret. I think the last group really trips everybody up right now is that seeing structure and generalizing because the verbiage is just a little more complex than we've seen in the past. But what they mean by that is helping students see structure in content that you're teaching and applying it to other areas. Like, for example, and I'll show you this later on in the presentation, if we're teaching the addition algorithm with whole numbers, help students see the structure of the addition algorithm of whole numbers and then generalize and say, oh, when I teach decimals, when you're teaching decimals, help students see that same structure applies for teaching the addition algorithm for decimals. So here are a couple of examples I'm going to show you for consistency, how our approach through every grade. I'm going to show you just samples of every grade level. Here's a lesson in grade 2 where we're teaching how to regroup with the addition algorithm. And the first standard for mathematical practice is with our opening word problem. We begin with a word problem, with problem solving. We want students to understand the problem. And then we use models as well as symbolic representation of the problem to model the mathematics. And then we attend to precision. Attending to precision is using the correct, accurate mathematical language to talk about math. And so here it is, we're solving a problem and we're showing how to solve that problem with a complete sentence, including units. So we're not saying 27 plus 27 is 54. We're saying no, Rose has 54 shells. Go back and look at the question and answer the question in complete sentence, including units. It's not just 54, it's 54 shells. And that'll help as students progress through the grade levels and then get into algebra. Here's an example in grade 3 where we're teaching facts, the multiplication facts for 4, where again we begin with a word problem. This time we're modeling with the number line. Modeling doesn't mean concrete materials. Modeling could be number lines as well. It can also mean number sentences and equations. And then again, we're tending to precision, answering a word problem, an exercise with a complete sentence with labels. Again, the answer is just not 24. There are 24 golf balls in all, making sure to include that label of golf balls. Here's an example of grade 5. Again, opening with a word problem, modeling with manipulatives, and again, tending to precision by answering the problem in a complete sentence with units. And this is one of the examples where you're looking for and making use of structure, where they understand the addition algorithm, where they have to add, they have to align the place values and add place value by place value. And again, that's where we're addressing the standard 7. Here's an example of in the middle school in grade 7. Here's where we're modeling mathematics with equations. And we're looking for and making use of structure and looking for and expressing regularity and repeated reasoning. Students have learned these properties in the early grades, and now they're applying what they know. They're making use of structure and applying what they know for properties with whole numbers to properties with integers. So now let's move on to the shifts in mathematics. There are 6 shifts in mathematics, as I've identified here, but I was actually at a conference and I attended a workshop at ASCD, the Associate Superintendents and Curriculum, Directors Conference in March. And I attended a workshop by Jason Zimba and David Coleman, two authors of the Common Core State Standards. And their presentation was on the 3 shifts. And I went up to them at the end of the presentation. I said, I just got my head around the 6 shifts, and now you're talking about 3. And they said, well, the 6 shifts were hard for people to remember, so we narrowed them down to 3. And if you're talking about the 6, you are talking about the 3 because fluency, deep understanding, application, and dual intensity are embedded, should be implemented with a rigor. And this information can be found at achievethecore.org, and I have that here at the bottom of this of my slide here for you to refer to. So I'm going to talk about the 6 shifts. I'm going to take you through the 6. So in actuality, I'm going to be addressing the 3. So let's start with the first one, the 6 shift, focus. And I'm going to be looking at these shifts through the eyes of the students, what the students should be doing. Students should be spending more time thinking and working on fewer concepts for mastery. And this is in response to the TIM study where the United States curriculum was criticized as being a mile wide and an inch deep. So what Common Core is doing is giving teachers the power of the eraser, and I think David Coleman coined this phrase. They're giving teachers the power of the eraser to significantly narrow the focus of the curriculum. So let's look and see what Progress did to address this. With our table of contents, we identified every lesson that aligns to the Common Core state standards. We identified each lesson with a Common Core logo, the CC, next to it. So if a lesson in the table of contents has a Common Core logo next to it, that means it specifically aligns to Common Core. Now, you might ask yourself, well, what do I do with these other lessons and why did you leave them there? We left them there because Common Core says that 70% of your focus should be on the Common Core, the core standards. 20% should be rethinking and linking those topics to other areas. So, for example, in grade 2, there is a standard on solving real-world problems involving money. But nowhere in Common Core, in grades kindergarten and first grade, are there standards about identifying the value of a coin of money and identifying coin recognition, bill recognition, and identifying the value. So how, when we get to grade 2, are students expected to understand that and master that standard? Well, Common Core is saying, we want you to teach money at kindergarten and first grade, but we want you to connect it to whole numbers. So that's the rethinking and linking, and that's the 20% that should be connected to the 70%, to that core. So we left those lessons in our program because you need to rethink and link the content to the core subjects, to the core topics. Another example is a grade 3 standard which states, interpret the product of whole numbers. Well, in order for students to be able to do this, they need to understand the meaning of multiplication as repeated addition, as skips on a number line, as skip counting, and these lessons are available in Progress. We did not eliminate them. Common Core didn't want those standards to be a checklist. They wanted you to interpret them. And we did this because here's just another example of the 70, 20, and 10. And what I did just on the side is I put where we address these topics in Progress in grade 4. And again, what Common Core is saying at grade 4 is, okay, your major focus is on the 4 operations, is on multi-digit whole numbers. It's on understanding of fractions. So connect your work with factors and multiples and measurements to these main areas. Connect your multiples to multi-digit arithmetic. That makes sense. So don't have it stand alone. Don't teach these in isolation. And then represent and interpret data on a number line. When you're teaching line plots, use fractions of a unit and connect fractions to data, to line plots. Here's an example in grade 6 where we're talking about ratios, proportions, and we're talking about multiplication, division of fractions, and expressions and equations. That's our major focus. But what Common Core is saying, hey, don't forget, rethink and link area, surface area, and volume. Rethink and link that to the multiplication and division of fractions. Rethink and link that to expressions and algorithms. So they're not, again, isolated topics. So that's your focus, and that's why we did what we did at Progress, so that you would have those topics there to lean on. So the second shift is coherence. We want students to build knowledge from within a grade level and year to year in a coherent learning progression. So each standard is not a new event, but it's an extension of previous learning. So what I'm going to do is show you several examples on how coherence is developed in our program, not only within a grade level, but across the grade level. And here's an example where we continue return to organizing principles to structure ideas. Again, this is grade 1. We taught tens and ones earlier in the year. What is a 10? What is a 1? Knowing that 54 has 5 tens and 4 ones, and now we're connecting this concept of comparing numbers, or a skill of comparing numbers, to tens and ones. Rethink and link. Fractions across the grade levels. We begin our fraction development in kindergarten. And if you look at the Common Core state standards, that's where the fraction development begins, is in geometry. The first explicit fraction standard begins in grade 3, but the actual fraction development in Common Core begins in kindergarten with by starting to compose simple same-size shapes to form one larger shape. And we do that in kindergarten. And as the development of fractions intensifies each year, so that students eventually become fluent with fractions and the 4 operations as they progress through the program. Here's another lesson in grade 3, and this is really important, and this is where Common Core, this is at the heart of Common Core. We are teaching the multiplication algorithm, but we want them to use the mathematical language, that knowing that 6 times 12 is not just 12, 6 times 2 is not just 12, it's 12 ones, and 12 ones is 1, 10, 2 ones. Many times we see students just rotely calculating and coming up with products, but not really understanding what that product means. So at the heart of Common Core is going back to those standards for mathematical practice and explain, what does that really mean? What does 6 times 2 really mean? 12 ones, and getting them to use that language. And again, we taught tens and ones in the earlier grade levels. I just showed you that in grade 1 and grade 2. So right now we're rethinking and linking. The major focus of grade 3 is this multiplication, and we're rethinking and linking it to place value. Here's another example across the grade levels where we're teaching multiplication facts in grade 3. As we move into grade 4 with the multiplication with regrouping, we're rethinking and linking across the grade levels to multiplication facts. And as we move up in the grades, we're generalizing and seeing structure for decimals. We're applying what we know for whole numbers, and we're using it for decimals and seeing that structure. And again, across the grade levels, you could see that development. Here's a middle school example where we're taking what they learned in grade 6 with one-step equations, applying it with grade 7 with two-step equations, and then building on that again with multi-step equations in grade 8. Again, coherence across the grade level. The third is fluency. The third shift is fluency. We want more students to spend more time practicing skills with intensity and at high volume. And if you remember the list I showed you earlier with the 6 shifts and the 3 shifts, here's where the rigor begins. This is where that third shift begins. And here are the required fluencies as identified by Common Core. And what I did here is I identified the Common Core state standards that are being addressed, the required fluencies, and where in progress in mathematics these fluencies are addressed. If you've done nothing else by the end of the year but brought students to fluency in these areas, then you've done your job. We need students to become fluent in these areas by the end of these grade levels. But fluency, how do you develop fluency? Developing fluency begins with conceptual development, with concrete, pictorial, and symbolic presentations, with a focus on multiple representations of skills and concepts, and a focus on strategies. This multiple representation is at the heart of Common Core. We need students to be able to represent skills and concepts in multiple ways, because that represents fluency, conceptual understanding. As we move, I'm just going to again show you examples. In grade 1, we start with the concrete presentation. We move on to the pictorial representation of addition, and then eventually connect it to the symbolic, again, trying to foster conceptual development and fluency. In the middle grades, in grade 3, here's a lesson on multiplication, where we're using counters. We're using that concrete presentation to introduce multiplication facts, showing it on a number line. Number line is very big in Common Core. We need to be able to show concepts on a number line. And then, again, showing multiple representations, showing a fact on a number line, representing it with counters, representing it symbolically. Moving on to grade 7, here's again an example using counters to represent adding integers, tiles, showing the pictorial representation on the number line. Again, multiple representations, and then again showing it symbolically. If students can move from the real-world problem, words, literal context, move that to an equation, represent those real-world problems as an equation. From the equation, represent it as a table of values, and from those table of values, represent it as a graph. These students that would lead them to fluency. Strategies help develop fluencies, and we present students with strategies throughout our whole program. Here are some strategies identified in grade 1 to help students with their addition and addition facts. Add up, add down, make 10, use doubles. Another big strategy in Common Core is to break apart numbers. We've always had this strategy in our program. Here's a grade 3 mental math lesson, again, having students solve problems quickly and accurately using mental math strategies and properties. Here's an example. It's a multi-step equation lesson in grade 8. Fractions and decimals make students crazy. They feel that they cannot solve these problems if they have fractions and decimals in them. So what we do is we try to present them with simpler problems. We provide them with a strategy. Here's a decimal. It opened up with a decimal word problem. Here's the equation. We translated it to an equation, and now we're giving them a strategy to solve the problem by multiplying both sides of the equation by 100, so that they get a familiar equation. Oh, okay, I know how to solve this. It's a whole number equation. I know what to do. Again, helping students become fluent using these strategies helps students become fluent. Here's, again, we open with a word problem for using fractions. Help students solve the equation by multiplying both sides by the LCD. Give them the strategy so that we give them a simpler problem, and they say, oh, I understand this now. I could solve this problem. This one is easy. The fourth shift is deep understanding. We want students to show mastery of material at a deep level in numerous ways. This means numerous ways they're communicating about math in terms of writing, modeling math. We want them to solve problems to understand the practices and demonstrate the understanding of different material and concepts. So the deep understanding begins with vocabulary development. If students do not have a good grasp on the understanding of math terms, they will not understand the math skills and concepts. So at every grade level, all our words are highlighted and defined in context. They're pulled out right out on the page, so students know the important terms that they need for a lesson. Online, we have an audio glossary in both English and Spanish where students can hear the correct pronunciation of the word and hear the definition as well. In the primary grades, we have a math word box. We pull these words out for the little kids and say, here are the key words that you need to know in order to master the skills and concepts of this lesson. And in the upper grades, we have a full page devoted to vocabulary development. Good questioning leads to deep understanding. Here are just a couple examples of questionings that I pulled out from our program. Sorry, they're a little fuzzy. But here's a nice one. How would you model this expression on a number line? Again, going back to the mathematical practices, you're modeling, you're explaining, you're making use of structure to model this on the number line. You know, modeling 2 addends on a number line is difficult enough, but modeling an expression is pretty difficult. So we want students to be able to do this because this is what they're going to start to see on the national assessments. Here's another question that I really like because I think the comparison meaning of subtraction and addition and subtraction really confuse children. How do you know whether to add or subtract when you solve a problem about comparing? That's really difficult. But here's where we want students to start reasoning about math, explaining math, modeling math, writing about math. And at the end of every lesson, we have our end of lesson features where we have a challenge, critical thinking, or do you remember it's a maintenance feature. Mental math, again, trying to promote fluency, and test preparation, not only in multiple choice, but free response as well. We have those at the end of every lesson. The fifth shift is application. We're still in rigor. We want students to apply math in other content areas. In the primary grades, we have centers in the teacher editions, connecting math to other disciplines. In the primary grades, we have a read and write and math lesson where we take students step by step using their vocabulary skills to decode a word problem, and we take them through step by step on how to solve the problem, connecting math and reading. We, in most skills lessons, open with a word problem. This happens to be a consumer example. We have lessons, technology lessons, connecting math and technology. Our enrichment lessons connect math to art and social studies and science. Our problem-solving lessons, this is at the heart of Common Core. Problem solving should be woven throughout. We want students to carefully read the problem. But plan is very big. We want them to be able to choose a strategy, and if that strategy doesn't work, plan another entry point. You know, give them several strategies, teach them several strategies, and if one doesn't work for them, try another one. Plan another entry point into to solving the problem. Solve the problem and check. Again, check is one of the biggest emphasis of Common Core because we want students to go back, read the question, and ask themselves, does this make sense to them? Does the answer make sense? And I know, I'm sorry I skipped this, but in the solve, again, we want them to answer the question in complete sentences with units, again, attending to precision. Problem-solving applications. These are great lessons throughout our program because students are asked to solve problems without explicitly being told how to. So for example, I'm not in an addition lesson, so I'm not just going to pull out the numbers and add. This lesson is a review of mixed skills and mixed strategies. So they really have to read the problem and understand understand the problem and figure out how to go about solving the problem. The sixth shift is dual intensity. We want students to practice skills with intensity, with which results in fluency. What I like again about this is participate in drills. Common Core is saying drills are okay. I've been doing this for a long time, for 25 years, and drill for the last 25 years was taboo. We were not allowed to do drills. But Common Core is saying drill is okay as long as it's of good quality. It's got to be good quality, the drills. So at the back of every math textbook in the student book, we have our mental math exercises where you could begin your lessons, just quick little brief um, exercises that help students lead to fluency. Still more practice. And in addition to the abundance of practice that we have in each lesson, we have still more practice at the back of the book, our maintenance feature. Our brain builders are for our challenging exercises to offer higher level math skills for those children who are ready to handle it. We have an abundance of practice online. We have timed math games. We have enrichment activities. We have hangman. We have problem of the day. But one of my favorite things are our virtual manipulatives. I actually did see an assessment question from one of the national consortiums. I'm not quite sure if it was Smarter or PARC, but one of the questions was for the students to model the multiplication of two fractions. Now, if anybody's ever tried to draw this diagram to model fractions, they'll know it's very difficult. So we have these free resources online. You can go to our virtual manipulatives and you can teach multiplication of fractions using this visual. By sliding these bars up and down, it changes the fractions that are being multiplied, and it also adjusts the diagram, the visual as well. And showing this visual leads to conceptual understanding, helps students visualize math. So I would really urge everybody to go to our website for the program. It's progressinmathematics.com. And Blair, if you wouldn't mind putting that in the chat so everybody could see that, they are free to all our users of our program, progressinmathematics.com, and you could see all our free resources there. So what I've done, and I've taken you through the 6 shifts. In essence, I've taken you through the 3 shifts. And while talking about the 6 shifts, and showing you examples of our program on how we address the 6 shifts, I've talked about the 8 standards for mathematical reasoning, mathematical practices, as William McClung has grouped them: problem solving and attending to precision, reading and explaining, modeling and using tools, and seeing structure and generalizing. What I'd like to close with, to be mindful of our 30 minutes that we have for this webinar, Sadler has a new web-based assessment system that allows you to build worksheets, tests, manage your class, and generate reports. Students take assessments online. And if you go to sadlerassessments.com and click on more information, there's more information there for you. What I'd like to show you is a brief 2.5-minute video on this, and then we'll come back and then take any questions that you might have on the either Progress in Common Core or the online student assessment system. So I will show you this video. Okay, so she says she's going to show its opening. Okay, here it comes. Sorry about this.
In the real world, children play digital games, use laptops, and talk on cell phones. So why not interact with them the way they interact every day? Sadler's web-based online student assessment system is a program to help guide instruction and monitor student progress that's easy to use and very accessible to teachers and students. Let's take a look at the online student assessment system for progress in mathematics. This program is grade-specific, customizable, and teacher and student-friendly. Teachers can create homework, practice worksheets, or tests using the ready-to-use question sets, or using the Progress in Mathematics assessments in the digital format, all aligned to the Common Core state standards. Here's how the system works. First, create a test using the question bank in the Test Generator section. Choose from over 550 dynamic and static items at each grade level, or create your own questions using templates from 15 different question types, ranging from multiple choice and free response to essay questions. In addition, learning objectives and the relevant Common Core state standards are associated with each question in the question bank. Instead of creating your own test, you can have the system automatically build a test based on a specific Common Core standard, or you can assign a test from the test bank, which includes over 100 tests from Progress in Mathematics at each grade level. Students sign in through a secure portal. Tests and other assignments are taken online, with responses automatically scored and recorded in the teacher's gradebook. You can generate reports for individual students, a group of students, or by the entire class. And you can generate proficiency reports on a specific lesson objective or Common Core state standard to monitor students' progress and help guide instruction. No other system is more flexible, customizable, or easy to use. It's fully web-based with no software needed. It's available 24/7 on any internet-accessible device. And it's the best way for your school to transition to the mandatory online assessments in 2014 to assess the Common Core state standards. Send your students out into the world prepared. Go to sadlerassessments.com and click on More Information to have a sales representative contact you.
Okay, I hope you enjoyed that, because that system is a very, very powerful system. Real excited that we came out with that. I would be more than happy to do a presentation for you and your staff. Should you like me to walk you through the exact features and benefits, a live demo of this? So please let me know. You could email me at jferrara@sadler.com. Should you have any questions regarding Common Core after this presentation and Progress in Mathematics, or our online student assessment system. Blair, I'm going to open it up to any questions we might have. Do we have any questions?
Yeah. Is there a correlation available for Progress in Mathematics to the Common Core state standards?
Yes. So if you would go to Sadler.com, and Blair, if you won't mind typing this in as well,
Yep.
It's Sadler.com/preview, PIMCC, and we have all our correlations for each grade level um, to the Common Core. And what I like, what we did with our correlations this time, instead of having a string of numbers for our correlations, because for me that would not be useful, what we did for each standard is we broke it down and said, here's where the readiness material is for this standard. Here's where the instruction is, the explicit instruction is to teach that standard. Here's where the application is of that standard, and here are additional teacher resources. So I'm glad we did it that way as opposed to providing you with a string of numbers, which I don't feel is that helpful. Any other questions?
Is there going to be a Common Core State Standards textbook running Common Core State Standard lessons off has been very costly and time consuming?
Okay, so are we taking
Is there going to be a textbook?
That I do not know. I have to get, if you can take that person's name down. Right now we are in our research and development stage of deciding what we're going to do with our next edition of Progress in Mathematics, but I don't have the time and date of that. So I would say definitely not for this next school year. So I apologize for that, but maybe there's something we could do.
Okay.
I'll have to get back to that person.
And can we get copies of the slides from the presentation?
Yes. So I will send everybody who participated in the webinar today, I will send them a thank you for attending, and we will include the PowerPoint as well. And then I will post it on our YouTube site. If you would type this in as well, Blair, if you go to youtube.com/Sadler School, I will post this there tomorrow. I will post the recording of this webinar there tomorrow. So we will definitely send you the slides, and you can also review the recording of this webinar.
Another question is, how do I schedule a demo of the online student assessment system for my staff?
Just send me an email and just let me know a date and time that's good for you, and hopefully that'll work with my schedule. And otherwise, I will try to accommodate you as best I can. I've been doing a lot of presentations lately, so just send me an email. My email is on the screen at jferrara@sadler.com, and I'd be more than happy to set that up for you.
And the last question is, how do I access Common Core resources online?
If you would go to progressinmathematics.com, select your grade level book cover, and click on the Common Core tab, there's all your free resources there. One other thing I should mention, going back to the online student assessment system, we also would be more than happy to set up anybody with a 14-day free trial so I know sometimes demos are great, but to actually get in and use the system is even more helpful. So again, if you have any questions on Progress in Mathematics and Common Core, please send me an email. If you have any questions on the online student assessment system, requesting a demo or 14-day free trial, again, please send me an email and I will respond. But just give me a day or two to put the email together to send you the PowerPoint presentation. Okay? Any more questions?
Nope, that was it.
All right. Well, I thank everybody for giving me their time, and have a good afternoon, everybody. Thank you.